Hello everyone, how are you guys? I hope you are doing well. My name is Akash Dev and I am a 21-year-old computer science student from IIT Arswai University, Bhubaneswar. And in my videos, I talk about different data structures and algorithms and topics related to computer science because I love computer science and currently I am reading this also. So it makes more sense for me to explain these things in front of the camera. So it would help me also and help anyone who is watching this video, help them also. Currently, I am doing this 30 days of talking to camera challenge, in which I will be talking in front of the camera for 30 days straight and consistently upload the videos on YouTube. I have missed some days like 2 to 3 days because I was not well, but I try my best to maintain the consistency. My only goal for doing this challenge is not because I want subscribers or I want views in my channel. That's okay if I get that, but my main goal here is to improve my communication skills and to improve my English speaking skills a little bit, so that if in future I get any chance to do public speaking or speak in front of a crowd or record a video, so in that case I would be prepared beforehand only. So I am just doing these things for that stuff only. And there are two types of learning. First one is just in case learning and second one is just in time learning. So what just in case learning says exactly means is you learn any stuff, and when you and you don't know whether you would be required needing those things in future or not. You just keep learning those things. And what is just in case, that means that just in case if you need to use those skills, so you would use this, or else you are just learning those skills. And what is just in time learning? Just in time learning means you are learning those skills at the time when you actually need them, like just before you need them. But both of these learnings are very useful. Suppose you have to just get 80% marks in your examinations and the subjects in your syllabus is not that much relevant for your future, so you would just learn those subjects just in time, like just before 2 to 3 days before the examinations, and you could get a good marks in your examination. I won't guarantee you that you could be the topper of your school or topper of your college, but you could get a decent like 80 to 85% marks in just studying for like just in time studying for like before the examination or before 1 week of examination. And what just in case learning is, like I'm improving my communication skills, so that in future if I ever get a chance to speak in front of a camera or give a public speaking or speak in front of an audience or speak in English, so I won't hesitate and my skills would be much better rather than if I wouldn't have practiced these speaking skills. So it would be much better compared to that time. Now both of these things are very important, because suppose you have to do a surgery, so you can't say in that place that okay, if I am a doctor, now I have to do surgery, now I will learn how to do a surgery. You need to learn those stuff beforehand. It doesn't matter whether in future you are going to use it or not use it, but these are the skills which you need to learn beforehand only. Like some fighting skills also. You won't say that okay, if someone would attack me, then I will learn how to fight and then I would defend myself. No, you need to learn these skills beforehand only. You never know whenever you get a chance to fight or you need to defend yourself, you never know. So these are some of the skills which require just in case learning, and my practice is just in case only. In this case, in recording my video, it's just in case if I require to speak myself in future. So that's why I'm learning this. And one more thing is that doing this challenge builds discipline inside of me. I'm thinking of recording a video of how many things I have learned in these 30 days and how much changes I have felt in my life in these 30 days. So let's see if I get a chance to record that video or not. And yeah, let's start this video. I spoke a lot regarding the like useless stuff, the stuff which was not regarding the topic. So now let's jump back to our topic. Now currently in my videos I will be talking about data structures and algorithm. Currently I have been recording videos on various algorithm designing techniques, the various data structures and algorithm steps and all those stuff. Previously I have talked about brute force algorithm, greedy algorithm, and I promised that today I will be talking about dynamic programming. But I realized that there is one more topic which need to understand before dynamic programming, and the name of the topic is divide and conquer algorithms or decrease and conquer algorithms. So today I will be discussing about these two topics, that is divide and conquer algorithms and decrease and conquer algorithms. And I won't go in much deep in these topics because I have already explained these topics in detail in my previous videos. So if you want more detailed explanation of these topics, you could just go and watch those videos of mine. And if you think my explanation is not clear, you could simply search the topic on Google and you could get a like very good article on that topic, and you could get a either you can also search on YouTube. Many people have explained these topics pretty well. Since I am not a professional in this field, I am currently also learning and explaining the same thing, so my explanation won't feel like very good to you. So yeah, it doesn't matter, because my goal is to speak in front of a camera, and until and unless I am doing that stuff, so it doesn't matter whatever I am speaking, and until and unless I am also making sense or not speaking anything useless. So let's start with today's video. First, divide and conquer algorithms. Divide and conquer algorithms works by dividing the big problem into smaller set of sub problems, then solving all those sub problems individually, and then combining all the sub problems at once. That is, combining all the solution of the sub problems at once. Now, what the definition of this says is, divide and conquer algorithms works by recursively breaking down the problem into two or more sub problems. This is also known as a divide step, as I have already told you, until these sub problems become simple enough so that they can be resolved directly. This is also known as conquer step. So first divide step and then conquer step. The solution of these problems is then combined to give a solution of the original problem. Now, there are three basic steps which divide and conquer algorithm has. First one is divide the problem into smaller parts, that is dividing step. First step is dividing step. Second is conquering by solving these problems, and the third one is combining the result together. So the three steps are divide, conquer, and then combine. In divide and conquer, the size of the problems is reduced by a factor. It could be half or 1/3 or 1/4. It could be anything. While in decrease and conquer, the size of the problem is reduced by a constant. So in divide and conquer algorithms, the main bigger problem is divided by a factor, that is 1/2, 1/3, 1/4. It could be anything. But in decrease and conquer algorithms, the problem is decreased by some constant. It is not divided by some factor. It is decreased by some constant. Now come some examples of divide and conquer algorithms. So what are some of the most famous examples of divide and conquer algorithms? Some of the most famous examples of divide and conquer algorithms are merge sort algorithm, which also uses we can also do it with recursion or without recursion. Then comes quicksort algorithm, computing the length of the longest path in a binary tree, computing Fibonacci numbers, recursion, convex hull problem. Example of decrease and conquer algorithm, computing power of a to the power n by calculating power of a and n by 2 using recursion, binary search in a sorted list, searching in binary search tree, insertion sort, graph traversal algorithm, that is DFS and BFS algorithm, topological sort, Warsaw's algorithm, permutations, minimum change approach, Johnson-Slaughter algorithm, fake coin problem, which is also known as ternary search problem, computing a median. So these are some of the examples of divide and conquer algorithm, and some of the examples of decrease and conquer algorithm. Now let's understand these algorithms. Before jumping to the algorithm, let's discuss the general divide and conquer recurrence. So the general divide and conquer recurrence is Tn equals to at n by b plus f of n, where a is greater than or equal to 1 or b is also greater than or equals to 1. Here n is the size of the problem, a is the number of sub problem in the recursion, and n by b is the size of each sub problem. Fn is the cost of the division of the problem into sub problems or merge of the result of the sub problem to get the final result, which is also known as the combine step, as I have already mentioned. Now our first problem is merge sort algorithm. I won't discuss these problems in much detail because I have already recorded a video on all these problems. So in this video I would just be discussing all the time and the space complexity and give a little bit of analysis of these problems. So what is the time complexity of merge sort problem? Since we are dividing the array each time into two equal sub arrays, so that it would take log n time complexity, and since we are merging each and every element once, so we are visiting through each and element one at a time, so it would take n time complexity. So my total time complexity would be big O of n log n. And what would be my space complexity? My space complexity would be big O of n. The time complexity of merge sort is n log n in all the three cases, that is worst case, average case, and the best case. As merge sort always divides the array into two halves, it takes linear time to merge the element. It requires equal amount of addition space as the unsorted list, hence this is not at all recorded for searching large unsorted list. Now comes our next type of sorting algorithm, which is quicksort algorithm. So what is the worst case time complexity of quicksort algorithm? The worst case time complexity of quicksort algorithm is big O of n square, and the best case and the average case time complexity of quicksort algorithm is big O of n log n. The space complexity of quicksort is big O of n log n. The space required by quicksort is very less, only big O of n log n, additional space is required. Quicksort is not a stable sorting algorithm, so it might change the occurrence of two similar elements in the array by sorting. Now our next problem is binary search algorithm. I have recorded a whole detailed video on binary search algorithm, so you please go and watch that video. In this video I won't be discussing in any much detail, as I have been telling this many a times. We get the middle point of the sorted list and start comparing with the desired value. We have to note one thing, that binary search requires the array to be sorted, otherwise binary search cannot be applied. The time complexity of binary search algorithm is big O of log n. If you notice the above programs, you should keep in mind that we always take half input and throwing out the other half. So the recurrence relation for binary suggests Tn equals to Tn by 2 plus C. Using a divide and conquer master theorem, we get Tn equals to big of log n. The space complexity of this algorithm is big of 1. Now our next type of problem is power function. So what is exactly is power function? We have to compute nth power of x using divide and conquer using recursion, and the input value is x and power n, and the output is x comma n. So this is a very simple problem. I don't think I need to discuss this problem. Now comes to our let's talk about our next problem, which is convex hull problem. We sort the points by x coordinate, divide the points into two equal halves a and b, and recursively compute HA and HB, merge HA and HB to obtain convex hull problem. So again that same similar divide and conquer approach, and what is the in this way similarly. So what would be the time complexity? Yes, the time complexity is very similar to the Mercator algorithm, because the steps used here is very similar to the Mercator algorithm. So the time complexity is big O of n log n, and the recurrence relation is 2t n by 2 plus big O of n, where big O of n time for tangent computation inside the merge step. Finally the time complexity is big O of n log n. Now our next type of problem, which is closest pair. Closest pair is our last topic for today. So let's complete it fast. Given n points in 2D plane, we have to find 2 points whose mutual distance is smallest. A brute force algorithm takes every point once and finds its distance with all the other points in the plane. In addition, keep track of the minimum distance point and minimum distance. The closest pair would be found in big O of n square time. Let us suppose that there is a vertical line which divides the graph into two separate parts. Let us call it left part and right part. In the brute force algorithm, we will notice that we are comparing all the points in the left half with the points in the right half. This is the point where we are doing some extra work. To find the minimum, we need to consider only 3 cases. First one is closest pair in the right half, second one is closest pair in the left half, and third one is closest pair in the boundary region of the two halves, that is gray region, which is in the between. Every time we will divide the space S into two parts, S1 and S2, by a vertical line. Recursively, we will compute the closest pair in both S1 and S2. Let us call minimum distance in space S1 as delta 1 and minimum distance in space L2 is delta 2. We will find delta min, which is the minimum of delta 1 and delta 2. Now we will find the smallest pair in the boundary region by taking one pair each from each S1 and S2, the boundary region for delta width on both sides, the candidate pair of point P, Q, where P belongs to S1 and Q belongs to S2. We can find the points that lie in the region in linear time, that is big O of n time complexity, just by scanning through all the points and finding that all points lie in this region. Now we can sort them in increasing order in y axis in just big O of n log n time, then scan through them and get the minimum in just one linear pass. Closest pair cannot be far apart from each other. Let us look into the next figure. Then the question is, how many points we need to compare? We need to compare the points sorted in y axis only in the region of delta. Therefore the number of points will come down to only 6 points. By doing this, we are getting equation Tn equals to 2Tn by 2 plus n log n plus 6n equals to big O of n log n square. Can we optimize this further? Yes, we can optimize this further. Initially, when we are sorting the points in x coordinate, we are sorting them in y coordinate too. When we divide the problem, then we traverse through the y coordinate list too and construct the corresponding y coordinate list for both S1 and S2 and pass that list to them. Since we all have y coordinate list passed to a function, the delta region points can be found or sorted in the y coordinates and in just one single pass in just big O of n time, which is Tn equals to 2Tn by 2 plus n plus 6n, which is equals to big O of n log n. First, pre-process by the time by sorting them in x and y coordinate. Use two separate lists to keep these two sorted points. Before recursively solving sub problem, pass the sorted list for that sub problem. So I hope this was clear. I have not delved into the detail of these topics. I have just tried to visualize these things a little. I haven't tried to actually visualize these topics in this video. I have tried to visualize these topics in my previous videos, which I have recorded in much detail for these algorithms. I have just go through to all these topics and just discuss about the time and space complexity and some little bit more idea about these topics. So if you find this video helpful, or if you think that if my communication skills have improved, so please hit the like button and consider subscribing if you find this channel useful. I will upload more videos tomorrow, and day after tomorrow I keep uploading. And there is one very good news, that with this video I have completed my challenge, and hats off to me and congratulate to me and anyone who has supported me through this journey. I have seen some of you have commented in my previous videos and some of you have liked the videos, so thank you so much for that. I haven't expected a single view through my entire 30-day journey, but still I have seen many views, likes and comments in my videos, so that makes me feel very happy, and yeah, that makes me feel very great. Although if someone has watched this video and found that I am just talking nonsense in this video and you are not able to understand a single thing, So please don't spread hate in the comments, because I have already told what was the main intention of me recording this video. You could just simply tell me in the comments, and I would then after record a proper video. Since in this video my main objective was to record, maintain consistency and to speak for in front of camera for 30 days straight. So I think I have accomplished that task very well. And if you guys comment, I will definitely record a very good, a very proper video in explaining these topics in very detail. I would take all your doubts and clear everything. Any doubt you face, you could ask me anything, any questions, anything, any data structures problem regarding these topics. So I would be very happy to help you guys. And one more thing is that don't think that if you think that my explanation was very bad, and so I am again saying that I am still learning these things. I am not a very professional teacher, or my communication skills are not very great. I know data structures and algorithm, that's why I decided to talk about these topics. My communication skills are not very well, so that's what I am learning. Hopefully in future I record a very great course in this particular data structures and algorithm topic for free for you all on YouTube. So yeah, that's the future. And that's all for this video. Thank you so much for anyone who have watched this video this far. Thank you so much. Bye bye. All the best for your journey.